All right, let's look over the questions on checkpoint number 4. So the first one here, we have a function that is the product of two like simpler functions. So we're going to have to use the quotient rule at some point to take a derivative. But the first part of the question doesn't actually require a derivative. So we're trying to find the average rate of change over this interval. So let's do that first. So the way we find average rate of change, you've been doing this for quite a while now. So I'm going to find g of 8 minus g of 2 all over 8 minus 2. If I plug in 8 for this function, what do I get? So let's just take some notes down here. G of 8 is equal to 8 minus 2 times the square root of 8 plus 1. So that's 6 times 3, that's 18. 18. And what is g of 2? G of 2 is equal to 2 minus 2 times the square root of 2 plus 1. So 0 times radical 3, that comes out to be 0. So 18 minus 0 over 6. Average rate of change is going to be exactly 3. All right, now I want to find g prime of x. So the way to find g prime of x is going to come from the derivative. So how do I find derivatives of functions that look like this? We're going to have to use the product rule because I have two functions multiplied by each other. So g prime of x is going to be what? It's going to be, so let me just underline what my two different functions are. I have a square root and I have this x minus 2. So the way to apply the product rule is this. I want to find the derivative of x minus 2. That's 1 times the second function not differentiated, basically just as is. So that's going to be the square root of x plus 1. Then plus, now we're going to leave the first function, x minus 2, unchanged. And then we're going to multiply by the derivative of square root of x plus 1. So how do we do that? So let's take some scratch work over here. What is the derivative of this thing? X plus 1 to the 1/2. So what's kind of hidden in this question is that we're also going to have to think about the chain rule because we kind of have an inner function and an outer function. So our inner function is x plus 1. Our outer function is x to the 1/2. So let's approach that from the outside in. What's the derivative of something to the 1/2 power? Well, it's 1/2 times that something to the negative 1/2 power. So that's handling the outer function there is using the product, or sorry, using the power rule. And I'm going to leave the inner function intact. Now, what does the chain rule say we have to do? The chain rule says we have to multiply this times the derivative of the inside function. So what's the derivative of x plus 1? That is 1. So all told, what do we have here? We're going to have 1/2 times 1 over square root of x plus 1. So let's clean this up a little bit. This is going to be the square root of x plus 1 plus x minus 2 over 2 radical x plus 1. So this is a good expression for our derivative. Yours might not be as simplified as mine, or you might have simplified in a different way, but I think this is this right here, anything equivalent to this is fine. All right, now I want to use that derivative to find the equation of the tangent line where x equals 3. So to find the slope of that line, I need to evaluate my derivative at g prime of 3. So g prime of 3 would be equal to the square root of 3 plus 1 plus 3 minus 2 over 2 times the square root of 3 plus 1. So that gives me a square root of 4, which is 2, plus 1 over 2 times 2. So 2 plus 1/4, or 9 over 4. So there's my slope. I want to find something of this form, y equals mx plus b. So let's take a what information do I really need? So I need M, which I just found, and I also need B. So I can solve for B if I have a value of X and Y that correspond together. So I have a value of X, that's 3. Now I need to find the Y that goes with it. So I'm going to find the value of the original function G when I plug in 3 for X. So G of 3 is equal to 3 minus 2 times the square root of 3 plus 1. So that's equal to 1 times the square root of 4, which is 2. So now I have a Y value. So 2 equals M, which is 9/4, times X, which is 3, plus B. So 2 equals 27/4 plus B, which means that B is equal to 2, which I'm going to call 8/4, minus 27/4, and that's equal to negative 19/4. So the equation for the line we were looking for is this: Y equals 9/4 X minus 19/4. All right, so that's all for question 1. Let's move on to question 2. All right, the Greyhound Bus Company found their monthly cost for some year in particular is given by this function. So C represents the cost in dollars. T represents the number of months into this year. They also found a similar function that gave its basically how many passengers it had at a given, or the company had in a given month. So part A, I want to make this new function R that gives the operating cost per customer. So I have a function that gives me the total operating cost, that's C. I have another function that gives me the number of passengers that Greyhound has. So if I want to find this like ratio of operating cost to customers, I'm going to take a quotient here. So basically C of T over P of T, and specifically 10,000 plus T squared over 1,000 plus T squared. So this is that function R. All right, so now that I have R, I want to find an expression for R prime of T. So I need a derivative. So I have a function that is basically one function divided by another. So I would like to use the quotient rule. So how does the quotient rule work? So similar to the product rule, but one thing we have to pay attention to. So in the product rule, you have two functions multiplied by each other. When we multiply things together, we don't care about the order. We're going to get the same result. And because of that, the product rule, it doesn't really matter which function you differentiate first. That's not true when you divide. The order truly does matter. So now we got to be really careful about, following the quotient rule exactly as it says. So what function do we take a derivative of first? We take a derivative of, so let's just write this down really explicitly. This is going to be C prime of T times P of T minus C of T times P prime of T all over P of T squared. So it really matters what order I do these things because, just like subtraction, the order matters. 7 minus 4 is not the same thing as 4 minus 7. So I got to make sure I get the order right. So what's the derivative of C? So the numerator here, that's going to be 2t. And then I multiply that by P of T, left unaltered. Then I subtract that by 10,000 plus T squared times the derivative of P, which is also 2t. And I take all of that and I divide it by 1,000 plus T squared. Let's simplify a little bit. So this comes out to be 2,000 T plus 2t cubed minus 20,000 T minus 2t cubed all over. I am not going to expand this. I think it's going to be simpler if I just leave it like this. But what does happen is I have these two terms cancel and these other ones combine into what? So negative 18,000 t over 1,000 plus t squared squared. I'm going to go ahead and stop there. If you kept on expanding or simplified this in a slightly different way, that's fine, but I think a correct answer has to be equivalent to what I have here. All right, now that I have this, I am asking us to evaluate it at t equals 8. So what's r prime of 8? I simply plug that into these places where I see t. So negative 18,000 times 8 plus 1,000 plus 8 squared is 64. Basically 1,064 squared. I found this answer a little bit ago, so I'll copy that down now. I'm getting a rate of negative 0.13. So part D is, what did we just do? So we found this value, negative 0.13, but what does it really mean? So first of all, let's remind ourselves of what R of T is. R of T gives basically the costs, the operating cost of Greyhound bus per customer. That's what R tells you. So then what does a derivative tell you? That tells you the instantaneous rate of change of R of T with respect to time. Okay, what does that mean? So in this right here, this is more or less general for any derivative. A derivative will always tell you the instantaneous rate of change of whatever the output variable is with respect to whatever the input variable is. So now let's unpack what these variables really say. So R of T says, R of T tells us the cost per customer, the total cost per customer of Greyhound for Greyhound bus to operate. So this rate of change says, what is that cost per customer doing? Like, is it increasing? Is it decreasing? And by how much? So we found a derivative of negative 0.13. So what we have really learned here is that cost per customer decreases by what? 13 cents. Per, I don't know, what does T stand for? Per month, because that is the units that our time was measured in, I believe. Yep. So that derivative tells us that our cost per customer is decreasing by 13 cents per month. That's an instant rate of change at, this value of time, T equals 8. All right, moving on to question 3. All right, so the percentage that an individual spends on food is given by this expression. So Y is a percentage. X is also a percentage of what? So the percentage Y that an individual spends on food is approximately this expression, where X is the percentage that the individual spends on recreation. So basically the percentage of, their overall budget. Okay, so moving on. A particular CGCC student finds that she is spending X equals this expression of her money on recreation, where T is measured in months since January 1st. So we have a couple different expressions here, a couple different functions. This upper one is a function that describes the percentage of her spending on food as a function of the percentage of her spending on recreation. And this lower function is describes the percentage of her money she spends on recreation as a function of, time after some reference time. So after the first of the year. So what does part A ask us to do? Part A asks us to, I want to make a function for the percentage of her money she spends on food as a function of t. So basically, I need to compose these two functions together. So y is a function of x is a function of t. Basically, I can put these things together. So y is equal to 33 times x to the negative 0.063, but I know what x is equal to. X is equal to 3.5 plus 0.1 t to the negative 0.63. So that's the function we want to make for A. So part B, what percentage of her money is being spent on food on November 1st? So how can I find that out? Well, Y is the percentage she spends on food. That's what I want to know. And the information I'm giving is, or the information I want to use kind of as data is November 1st. So I want to, for part B, and one of the things I was hoping to get you all to, kind of see the differences here is, when do I use the function, when do I use the given function, and when do I need a derivative? In this case, I don't need a derivative. I just want to know what the percentage of her money she's spending. I'm not looking for the rate of change. So for this, I want to know what happens, what the value is of y when t is equal to 10. So that's 33 times 3.5 plus 0.1 times 10. That's 1 to the negative 0.63. Wrote this answer down a while ago. All right, so this value comes out to be 12.79. So basically, she is spending 12.79% of her money on food on this date, on November 1st. All right, part C, what does it ask? How fast is the percentage of her spending on food changing? So this is the one that asks us for a derivative. It doesn't really come out and say derivative, but what are the kind of key phrases here that tell me that I want a derivative? So how fast, that indicates a rate of change. And that's probably the biggest clue that I really want a derivative. I'm not asking what the percentage of her money that she spends is. I'm asking for how that percentage is changing. Is it going up? Is it going down? And how significantly. So now what I really want is, I want y prime of t. So now I'm going to have to take a derivative of that function that I made in part A. So we're going to have to use the chain rule here, because I have a function nested inside another function. So our outer function here is 33 times something raised to this power. So how do I find a derivative of that? Well, I can use the power rule for that. So the power is negative 0.63. I want to multiply that by the original 33. When we do the outside layer of the chain rule, I don't care what the inner function is. I just have to leave it alone. Basically what I'm doing is I'm taking a derivative of the outer function with respect to whatever the inner function is. So for right now, I'm just leaving the inner function as is. So I brought down the exponent of negative 0.63 to multiply by this expression. What do I do with the power now? That gets decreased by 1. So this becomes negative 1.63. And we're almost done with the chain rule, but the last thing I have to do is this. I have to, now that was the outer layer of the chain rule. Now I have to multiply this by whatever the derivative of the inner function is. So the derivative of the inner function is going to be 0.1. So we can clean that up a little bit. Actually, the only thing I'm going to do, just to kind of show the different pieces here, I'm going to change that 33 to a 3.3. So one thing I'm going to say here is another reason I don't really want to simplify this very much is because I'm not really looking for a simplified expression. I am looking for a value of this thing at a certain, period or certain instant in time. So I found the derivative because I'm asking you how fast this percentage is changing. The other information I need is this date, November 1st. I need to know, basically, I can't get an exact number unless I have an exact number or like a specific number for the input. That's also going to be t equals 10. So y prime of 10 is going to be equal to negative 0.63 times 3.3. If I plug in 10 for this, again, I get times 4.5. And this is raised to the 1.63, sorry, negative 1.63 power. So wrote this value down as well. This comes out to be negative 0.179. So that's the numerical value. But let's talk about what that means. So it's a negative number, which means what's happening to her spending on food on this date? Well, the percentage of her money she's spending on food is going down. And by how fast is it going down? It's going down by 0.179 percentage points per month, essentially. So I'll give that. So negative 0. So let's just write a complete sentence here. The percentage of her budget spent on food is decreasing by 0.179 percentage points per month on November 1st. So I think that's a very complete way to say what is happening based on what these functions are saying at this time. And that is all for checkpoint 4.